So good morning all. So let's discuss the Belman Ford algorithm. The Belman Ford algorithm is a single source shortest path algorithm. So we have already studied Dijistra's algorithm, which is also used as a single source shortest path algorithm. So now the difference between Dijistra's and Belman Ford is, in Dijistra's the working is based on greedy technique, and Belman Ford the working is based on dynamic programming. So and in Digistra's it allows only positive weights, and the Belman Ford algorithm allows negative weights also. So now let us consider a graph. We'll take source as 1 and we need to find the shortest path from source 1 to all other vertices. So first we will represent the graph as a weighted or a cost matrix. So now here we have 7 vertices, and distance from one vertex to the next vertex, it contains both positive and negative edges. So now let's represent this. Okay, so now to solve this, as we know in dynamic programming, we will construct a table. So in the first step we need to find the distance from source to source with different edges. So now here in this table, so we have rows as edges and columns as vertices. So now the graph contains 7 vertices. So here we have written 1, 2, 3, 4, 5 and 7 columns. And if I have 2 vertices, between 2 vertices I can have 1 edge. Between 3 vertices we can have 2 edges. In the same way for 7 vertices we can have 6 edges. So there are 6 edges represented as rows, 7 vertices represented as columns. So now here the equation distance of 1 k means here k indicates the number of edges and distance of 1 indicates the distance from source to vertex 1 with k edges. So now here when k is 1, so then we need to find distance from source to 1 with 1 edge. When k is 2, distance from source to 1 with 2 edges. So now here, so distance from source to source will be always 0 whether it is with 1 edge, 2 edge or 6 edges. So here we have written in the table distance of source to 1 with 1 edge as 0, distance from source to source with 2 edges, that is second row, also 0, distance from source to source with 3 edges, third row also 0, distance from source to source with 4 edges 0, distance from 4 to source to 1 with 5 edges, distance from source to source with 6 edge also 0. So here we have done first column as 0 means distance from source to source with any number of edges is 0. So now next we need to find distance from source to all other vertices with 1 edge. So now here distance of 2 with 1 edge. Distance of 2 with 1 edge means here distance from source to vertex 2 with 1 edge. Source is 1, 1 to 2 with 1 edge is 6. Distance from source to 3 with 1 edge. Source is 1, to reach 3 with 1 edge is 5. Distance from source to vertex 4 is with 1 edge is 5. Now distance from source to vertex 5 with 1 edge. Is there direct single edge from source to vertex 5? No. So it is infinity. Similarly, distance from source 1 to vertex 6 with direct edge. Is the direct single edge from 1 to 6? No. So again it is infinity. Similarly, distance from source 1 to vertex 7 with single edge. There is no such single edge from 1 to 7. So again it is 0. It is infinity. So we have filled the first row. So distance from source to all other vertices with one edge, that is direct edge, we have written 1 to 1 0, 1 to 2 6, 1 to 3 5, 1 to 4 5, then 1 to all other vertices it is infinity. So now we need to find distance to 2, means here distance from source to all other vertices with two edges. So now this can be calculated as minimum of distance from source to, for example here vertex 2 with one edge, as we have calculated already. Distance from source to vertex 2 with one edge is 6 comma minimum of distance from source to other vertex with one source to the immediate vertex with one edge plus cost of the vertex to 2. So now in this way we have to find distance from source to all other vertices like vertex 2, vertex 3, vertex 4, 5, 6, 7 with 2 edges. So now here if I take the distance first row, that is in the right uh, font, red color font. So distance from source to vertex 2 with two edges is minimum of 6 comma, that is 6 is 1 to 2 with one edge, 1 to 2 with one edge is 6 comma 0 plus 6, 0 plus 6 means source to 1 is 0 plus 1 2 is 6, then 5 minus 2 means source to 2. So because here we are calculating for 2 itself, so then source to 2 is, no need to write, then source to 3, how much, 1 to 3 is 5 plus 3 to vertex 2, 3 to vertex 2 is minus 2, okay, 5 minus 2, then source to vertex 4, it is 5 plus 4 to vertex 2, either it's from 4 to 2 directly, no, so it is infinity. Then source to vertex 5 infinity, again 5 to 2 is also infinity. Next source, that is 1 to 6 is infinity, 6 to 2 infinity, 1 to 7 infinity, and 7 to 2 is infinity. So now among these the minimum value is 5 minus 2 3. So the shortest distance from source vertex 2 with two edges is 3. Similarly we have calculated shortest distance from source to vertex 3 with two edge, source to vertex 4 with two edge, source to vertex 5 with two edge, source to vertex 6 with two edge, source to vertex 7 with two edges, and we got the second row like this. Here we have highlighted with the different color. So now from source 1 to vertex 2 with the two edges is 5 minus 1, 5 minus 1 is 3. So here in second row second column is 3. Then source to vertex 3 with two edges is 5 minus 2, it is 3. Then source to vertex 4 done. Then source to vertex 5 is, in red color we have written 6 minus 1 5. Then source to vertex 6 with two edges, 5 minus 1, it is 4. Source to vertex 7 with two edges, there are no two edges from source to 7, so it remains infinity. In the same way if I continue, so next we got the row for source to all other vertices, that is from source 1 to vertex 1 2 3 4 5 and 6 7 with 3 edges, that is here row 3 indicates with 3 edges, column 1 2 3 7 indicates the destination starting from source 1. Now from starting from source 1 to source 1, that is 0 already done. Source 1 to vertex 2 with 3 edges, so we can see that particular color, so violet color, so that is that green color. 5 minus 2 minus 2, how much, 1. Then 3 source to vertex 3 with 3 edges, there are there are no 3 edges from 1 to 3, so we'll keep the previous value. Then 1 to 4 with again 3 edges, there are no 3 edges from 1 to 4, we'll keep the previous value. Now source to vertex 5 with 3 edges, we can see the red color, 1 to 3, 3 to 2, 2 to 5, that is 5 minus 2 minus 1, we got it as 2. Compared with the previous row value from source to vertex 5 with 2 edges is 5. Now source to vertex 5 with 3 edges is 2, minimum is 2. Similarly 1 to 6 with 3 edges, we don't have 3 edges from 1 to 6, so we'll keep the previous value. Now 1 to 7 with 3 edges, with pink color we can see 1 to 4, 4 to 6, 6 to 7, 5, that is 5 minus 1 plus 3, it is 7. So now in the third row we got the shortest distance from source to all other vertices with 3 edges. So next is with 4 edges. So again we can see with different colors I have specified. If there are no changes, if we will not get the minimum value, we will keep from the previous third row, otherwise we have to change. So here only 2 values will change because we have only 2 points from source to other vertices. Only 2 other vertices are having shortest distance with 4 edges. First one I have given with a red color, a green color, that is 1 to 5 with 4 edges. So 1 to 4, 4 to 3, 3 to 2, 2 to 5, that is 5 minus 2 minus 2 minus 1, we got it as 0. Shortest distance from source to vertex 5 with 4 edges is 0, and then source to vertex 7 with 4 edges is that I have given with the pink color. So 1 to 3, 3 to 2, 2 to 5 and 5 to 7, it is 5 minus 2 minus 1 plus 3, I got it as 5. So when comparing 5 with the previous value 7, 5 is the minimum, we have to keep 5 itself. Now for other vertices we are not getting the minimum value, we will keep as it is from the third row. So what is the next step? Now we need to find distance, shortest distance from what source vertex to all other vertices with 5 edges. Now again in the fifth row what we can see, all values are same from fourth row, 0 0 1 1 3 3 5 5 0 0 4 4, but in the last column, that is the shortest distance from source to vertex 7 with 5 edges. So if I see the pink color, with 5 edges to reach from source to vertex 7, 5 minus 2 minus 2 minus 2 minus 1 plus 3, it is 3. So shortest distance from source to vertex, what is the source here? Source 1, source 1 to vertex 7 with 5 edges is 3, and all other values are same as previous. So now finally, as for 7 vertices we have 6 edges. Now we have to find shortest distance from vertex 1, source 1 to all other vertices with the 6 edges. And now here you can see there is no shortest minimum value compared to the previous row. So sixth row contains the same value, 0 1 3 5 0 4 3, same as our fifth row. So now here we have completed our Belman Ford algorithm, and we got the shortest distance from source to all other vertices. So now if I can cross verify with our graph, the distance, shortest distance from source 1 to vertex 1 is 0, source 1 to vertex 2 is 1, that we have seen here. Then source to vertex 3 is also vertex 3 with 6 edges is 3. Then source to vertex 4 with 6 edges is 5. Source to 5 is 0. Source to 6 is 4. And source to 7 is 3. So this concludes our Belman Ford algorithm to find the single source shortest path to all other vertices. Thank you.